Welcome our dear students. Our lesson today about geometry, first secondary, first term, with you Mr. Ibrahim الدسوقي. First lesson is similarity of polygons. Two polygons are similar if the corresponding angles are congruent, or we can say the corresponding angles are equal in measure, and the corresponding sides are proportional. As here, measure of angle A equals measure of angle E, measure of angle B equals measure of angle F, measure of angle C equals the measure of angle G, and D equals H. The corresponding angles are equal, and the corresponding sides are proportional. What is the meaning of it? AB over EF equals the same ratio BC over FG equals CD over GH equals DA over HE. This ratio is called scale factor or similarity of ratio of similarity. Okay? The scale factor, if it's greater than 1, then we have enlargement or ratio of enlargement. If the scale factor is smaller than 1, then we have reducing or shrinking. If the scale factor equals 1, then the two polygons are congruent. Therefore, any two congruent polygons are similar, but the converse is not necessary. Okay? Here two polygons are similar if the corresponding angles are congruent and the two conditions satisfied. Two corresponding sides are proportional. What's the meaning of regular polygon? Regular polygon is the polygon with all sides are equal in length and all angles are equal in measure, such as equilateral triangle, square, regular octagon, and so on. All regular polygons with the same number of sides are similar, such as all equilateral triangles are similar, all squares are similar, all regular pentagons are similar, and so on. Two polygons ABCD similar to polygon XYZL, then the corresponding sides are similar. We can take the corresponding sides from the letters. Okay? The first two letters, which is AB over the corresponding side there, XY equals BC over YZ equals CD over ZL, and it takes the first letter and the last letter, which is DA over LX equals K. K such as 2. And this ratio bigger than 0 is positive. Okay? Now, if I'm going to start from the sides of the second polygon, then we have the reciprocal of K. If K is 2, then its reciprocal is 1 over 2. Okay? Remark, as we said, if the K bigger than 1, then we have enlargement. Okay? If K is smaller than 1, we have shrinking or minimizing. And if K equals 1, then we have two congruent polygons. Example. In the opposite figure, ABCD similar to XYZL. Okay, as we see. We want to find the scale factor of similarity of polygon ABCD to XYZL. Now, the corresponding sides are proportional. We prefer take the corresponding sides from the letter because one of them is rotated. Okay? AB over XY equals BC over YZ equals CD over ZL equals AD over XL. Okay? And substitute AB over 3 equals 2.1 over 1.4 and so on. Then the scale factor, we can get it from this fraction. 2.1 over 1.4 equals 3 over 2. We wanted to find the length of the unknown sides and the measures of the unknown angles. Okay? We know that the two polygons are similar, then the corresponding angles are equal. Therefore, here we want to find AB by cross multiplication. AB here equals 3 times 2.1 over 1.4. CD equals 2.1 times 1.8 over 1.4, and so on. We can get LX equals 1.4 times 3 over 2.1 gives me 2 centimeters. Okay, two polygons are similar, then the corresponding angles are equal. Measure of angle A equals measure of angle X B equals Y, C equals Z, and D equals L. We have three angles. Measure of angle X equals X here equals A, which is equals 70 degrees. B equals Y equals 65 degrees, and Z equals C equals 135. We know that the sum of the interior angles of any polygons equals 360 degrees. And we have three angles, which are 70, 65, and 135. We can get the measure of the fourth angle equals 360 minus the sum of these angles gives me 90 degrees. Another example. We have triangle ABC with sides 4, 5, 8 centimeters. We want to find another triangle similar to it with a scale factor 2.4 bigger than 1, then we have enlargement. And second one, 0.7 smaller than 1, then we have minimizing. To get the sides of the new triangles, you must multiply each side by the scale factor. Multiply 4 by 2.4, 5 times 2.4, 8 times 2.4. As we see, 4 times 2.4 equals 9.6, 5 times 2.4 equals 12, and 8 times 2.4 equals 19.2. The same, the second one, multiply each side by 0.7 gives me 2.8, 3.5, and 5.6. Now we have the second lesson, which is similarity of triangles. Okay, we have three cases. First case is AA, and each one of these cases is enough. Only one case. Okay, the first case is AA. What's the meaning of AA? Angle. If I have two angles of triangle congruent to the corresponding angles of the another triangle, then the two triangles are similar. Here we have measure of angle K equals measure of angle H, M equals J. Therefore, L equals I, because if we have two angles in triangle equal another two angles in another triangle, then the third angles are equal also. Then we have two similar triangles. K equal H and the M equals J. Two angles is enough, therefore two triangles are similar. Case number 2, SSS, side. Two sides is not enough. If the sides of triangle are proportional with the corresponding sides of another triangle, then the two triangles are similar. As we say, we have two triangles ABC and DFE with sides 8, 10, 14, and 12, 15, 21. If we divide 8 by 12, gives me the same ratio if we divide 10 by 15 and 14 divide 21. Each of them gives me 2/3. Then the corresponding sides are proportional, and then the two triangles are similar. Case number 3, SAS. What is the meaning of SAS? Two sides and the including angle. Two sides and the including angle. If an angle of one triangle is congruent to an angle of another triangle, and the length of the sides including those angles are in proportion, then the triangles are similar. As this figure, we have AC 4 cm and AB 3 cm, and the including angle, which is angle A. There we have PR and the PQ with sides 8 and 6 cm, and the including angle here is P. A equals P, and the sides are proportional. How? 4 divided 8, we can know that equals a half. Also 3/6 equals half. Then we have two sides are proportional and the including angles are equal. Corollary. I have triangle ABC. If I am going to draw DE parallel to BC, then we have two triangles. Then these two triangles are similar. Why? Because A is an including angle, or A is a common angle. What's the meaning of common angle? Angle A exists in the first triangle, which is ADE, and completely exists in another triangle, which is ABC. And the measure of angle B equals the measure of angle ADE, corresponding angles. Measure of angle C equals the measure of angle AED, corresponding angles. Okay? If I'm going to draw DE outside the triangle, also triangle ABC similar to triangle ADE. Angle A is a common angle. D equals ABC, corresponding angles, and E equals ACB. Okay? Here, measure of angle E equals C, alternate angles. B equals D, alternate angles. And we have vertically opposite angles, DAE with measure of angle BAC. Okay? Therefore, if we have parallel lines inside the triangle, then we have two similar triangles. Another corollary, I have right angle triangle, and I'm going to drop from the right angle perpendicular to the hypotenuse. Then we have how many triangles? We have 3 triangles. All of them are similar. Why? Because we have 3 right angle triangles. BAC is right, BDA is right, and measure of angle ADC is right. And we have measure of angle BAD equals the measure of angle C. And measure of angle B equals the measure of angle DAC. The order of letters here is very important. Triangle DBA similar to triangle DAC, similar to triangle ABC. We want to remind the Euclidean theorem because we have right angle triangle and perpendicular from the right to the hypotenuse. We have 4 cases. Number 1, BA power 2 equals BD times BC. In another side, CA power 2 equals CD times CB. What about the hypotenuse? Or what about the height or altitude AD? DA power 2 equals DB times DC. The last one, AB times LAC, which is the sides of right angle, equals the hypotenuse times the height. AB times LAC equals the altitude AD times the hypotenuse BC. Example, I have 2 triangles. I wanted to prove that the 2 triangles are similar. We have all side lengths. Then we can prove it by using SSS. Okay? It's preferred to find the corresponding sides from the letters XY over LX, YZ over XZ, XZ over LZ, and substitute. XY over LX equals 30 over 20 in simplest form equals 3 over 2. Also YZ over XZ equals 36 over 24, also equals 3 over 2. And XZ over LZ equals 24 over 16 equals the same ratio, which is 3 over 2. Then the 3 sides are proportional. Therefore, the 2 triangles are similar. Another example. We have 2 triangles. We want to prove that the 2 triangles are similar. This is the first, as we did in the previous example. And the new one, BD bisects the angle ABE. The same steps. AB over BE gives me 4 over 3. BC over BD equals 4 over 3. And the AC over DE equals also 4 over 3. Then the corresponding sides are proportional. Therefore, the 2 triangles are similar. From similarity, the corresponding angles are equal. Therefore, measure of angle ABC equals the measure of angle EBD. Right? Okay. Therefore, BD bisects the angle ABE. Another example, we have triangle and we have parallel inside it. Therefore, the 2 triangles are similar. Since DE is parallel to BC, therefore, triangle ADE similar to triangle ABC. With the steps, because A is a common angle, okay, measure of angle ADE equals the measure of angle B corresponding angles, and the AED equals the measure of angle C corresponding angles. Therefore, the 2 triangles are similar. Okay? Therefore, the corresponding sides are proportional by substituting AD drop as it is. AB here equals AD plus 1.2. Okay? AE equals 3, AC 4, DE equals 4.2, and the BC drop as it is. Cross multiplication. The product of means equals the product of extremes. 4 times AD for AD. 3 times AD plus 1.2 distribute 3 gives me 3AD plus 3.6. 3D comes here from by negative Sine 4AD minus 3AD gives me 1AD, therefore AD equals 3.6, and we can get BC by using cross multiplication. 4 times 4.2 over 3 gives me 5.6. Okay? Another example, we have triangle ABC with the sides. We want to prove that the two triangles are similar by using SAS, because we have B is a common angle. B here is a common angle, and here is the first letter, and here also the first letter. Okay, therefore B is a common angle. We want to prove that the two sides are proportional. BD over BA equal 4 over 6 equal half. BE over BC equals 6 over 12 equal also half. Then we have two sides are proportional, and the including angles are congruent. We have common angle, therefore the two triangles are similar. From the similarity, we have the scale factor, which is half, therefore DE equals half AC equals 5 centimeter. We want to prove that ACDE is a cyclic quad. Let's remind the cyclic quad. We have 3 conditions. One of them is enough. First one, if the two angles drawn on the same side are equal, or the opposite angles are supplementary, or the exterior angle at a vertex equals the interior angle opposite to it. From similarity, we can prove that BDE equals the measure of angle A, and BDE is an exterior angle of the quadrilateral AEDC, therefore the figure is cyclic quad. Another example, in each of the following figures, find x. Okay, we have right angle triangle and the altitude, then we can use Euclidean. Here, dB power 2 equals dC times dA. Therefore, x power 2 equals 8 times 18 equals 144. Therefore, x equals the positive root 144 equals 12. Another one. Also here, EC power 2 equals EB times ED. Therefore, 4 times 2x plus 1 equals 6 power 2. 4 go there, divided. Therefore, 2x plus 1 equals 6 power 2 over 4. 36 over 4 equals 9. Therefore, 2x equals 9 minus 1 equals 8. Therefore, x equals 4. Thank you. Good luck.